All right, so we're going to be finding characteristics of polynomials. So what does that mean? What am I going to find? Domain and range, and max and min, and increasing and decreasing, and X-intercepts, and Y-intercepts, and continuity, and end behavior. All the things we've found a million times. All the things. So you do need a calculator. I do expect you to type things into your calculator and find them as we go. Okay, I'm not doing this on my calculator for you. You're going to do it on your calculator as well. So the equation that we're going to use is y equals negative x to the fourth minus 2x to the third plus 2x squared plus 3x minus 1. And we're going to start off by graphing that in our calculator. And the graph is a little bit easier to see if you make the window kind of like more zoomed in. So when I look at the stuff that's happening, my window right now goes left 10 and right 10, but I could cut it down and say like left 5, right 5 and still see everything. And it goes down 10, up 10, but I could cut that down and do like down 5, up 5 and still see everything. And so I'm going to change my window to be negative 5, 5, negative 5, 5. So it's going to have the effect of zooming in. And we're going to go ahead and start off by finding X-intercepts. How many X-intercepts do we have? Thank you, ma'am. How many? Yeah, we got 4. And that fits, right? The degree is 4, so we would expect to find 4 X-intercepts. And since we can see all 4, that means that all 4 of them are real. So I'm going to go ahead and draw a sketch of this. Doesn't have to be perfect, but just so I can kind of label the stuff that I'm about to do. Kind of looks like that. So I'm looking for the X-intercepts right now. Can somebody remind me how we find X-intercepts? Second trace, 0. So we're going to do second trace number 2. We're going to do left bound and right bound for all of these. So second trace, option number 2. So left bound, right bound. And when we write our X-intercepts today, a lot of them are going to be decimals, and we're going to do 3 decimal places. So this one would be negative 2.194, comma 0. And I'm going to let you guys go ahead and find the other 3. How are you guys doing finding the X-intercepts? Good? So we can do our left bound and right bound. We can find them. Luis, you finding them? No? You got it typed in? All right, so there's the 4 x-intercepts you should have found. Go ahead and make sure that you got them right. So negative 1.295, 0.295, 1.194. Did we get them? So at this point, we should be able to get x-intercepts no problem. We've done it several times now, right? Through all the units. Okay, how do we find a y-intercept? Second trace number 1, and you plug in 0. So second trace number 1, plug in x equals 0. All right, so go ahead and do that. And then what'd you guys get for your y-intercept? 0, negative 1. Marvelous. Okay. We're also going to go ahead and look for maximums and minimums. So if you guys remember, a max will look kind of like a mountaintop. And if we look at this picture, we actually have 2 of them. So we're going to find a max twice. So how do I find a maximum? Second trace number 4. Okay, so maximum, second trace number 4. We're going to have 2 answers for this one. So my first mountaintop is over here, so I'm going to scroll all the way left. So there's about where I think the mountaintop probably is. So I need to go to the left of that for my left bound, and then I need to go right of the mountaintop for my right bound. And we're going to do 3 decimal places again. So the first max is negative 1.823. Is the x-coordinate, and then 1.25 is the y-coordinate. And then go ahead and do the same thing to find your other max. So second trace, number 4. And then for your other max, you should have had 0.823, 1.25. You guys get the other max okay? Okay. And then we're going to look for a min, and this one only has 1 minimum. It's got 1 place that looks like a valley. So for that, we're going to do second trace number 3. Okay. So second trace number 3. The valley looks like it's right down here. So I'm going to do left bound and right bound. And I'm going to do 3 decimal places. What is the calculator trying to say for the x value? It's repeating, so what do you think it's trying to get to? Negative 0.5, yeah. Negative 0.499999999. It's trying to say negative 0.5. It's having a hard time. So we're going to say negative 0.5. And then we've got negative 1.813 for the y-coordinate. Okay. What are some other things we typically find? Say it again. The end behavior. Yeah, we could look for that. So end behavior. So I'm going to say, as I look to the left arrow, is the left arrow pointing up or is it pointing down? Down. So I'm going to say, as I look left, the y value goes down. Left arrow is a down arrow. As I look to the right, which way does the right arrow point? Down. So as I look to the left, it goes down. As I look to the right, it goes down. What else do we look for? If it's continuous, is this graph continuous? Yep, you can trace it with your finger. Okay, so we're going to say the graph is continuous. What else do we look for? Yep, domain and range. So the domain is from the left side of the graph to the right side of the graph. So what do you guys notice? So it goes left forever, right forever. Which infinity do we write first? So negative infinity on the left side, positive infinity on the right side. What about for the range? So the bottom of the picture is arrows going down, so that's why it's negative infinity. And then for the top of the picture, we can see it does not go up forever. It goes up to the maximums, right? So we have to check the maximums and see which one of them has a higher y-coordinate. And what do you guys notice about the y-coordinate? They're exactly the same, so we're just going to use the y-coordinate, 1.25. Does that get a bracket or a parenthesis? It's a bracket because that's a real point on the graph. It actually gets to that number. Okay, and then last, our favorite. We don't really have a vertice for this, or a vertex for this, no vertices. We don't really do transformations for these. The roots are the x-intercepts, so we already did those. That's another word for it. Increasing and decreasing. Okay, so I'm going to go ahead. For these, I would say, because these increasing and decreasing are probably with the exception of piecewise functions, these are probably the most difficult increasing and decreasing we do all year. So what I'm going to ask you guys to do is draw like a big sketch, and we're going to label it, because I have found that students do much better with these when they have a picture that's labeled. So if we put our stick figure right here, what is he doing first? Increasing. And then he hits the mountaintop. And what happens after the mountaintop? He decreases. And then he hits the valley. What happens after the valley? And then he hits the mountaintop. What happens after the mountaintop? Decreases. Okay. What is the x value of a left arrow? What is the x value of a right arrow? Positive infinity, because we're thinking that it's going to the right. We don't care that it's going down. We're just thinking about the right. What was the x value of the first maximum? Okay, negative 1.823. What was the x value of the minimum? Negative 0.5. What was the x value of the other maximum? Okay, so once you have this picture drawn, you can write your increasing intervals and decreasing intervals. So for increasing, there's my first interval right there. What should I write? And should we use parentheses or brackets? Parentheses, always parentheses when we do increasing and decreasing. So I have negative infinity to negative 1.823. That's my first set of answers. Okay, the next one is decreasing, so I'm going to ignore that. Then I have another increasing interval, and what should I write for this one? So we're going to say u negative 0.5 comma 0.823. Thank you. And then for decreasing, what should I write for decreasing? Okay, and then the other decreasing. Okay. So that is what we are focusing on today. This is a very calculator-heavy day. You're using your calculator for every little thing. X-intercepts, Y-intercepts, maxes and mins, increasing and decreasing. Make sure you notice, and this is, you should put this, maybe let's actually write this like big. For increasing and decreasing, we use X values. Write it big. I can't even hear you guys writing it. Write it big. I should hear you writing it. X values. Look at you guys following instructions. I love it. I love it. X values. My S is getting out of control. All right. So what values do you use for this? X values. Nick, I'm about to beat you up after school. X? Almost X. I did throw a shot put in college. And shot puts, as you guys know, maybe, back in the day were used to kill people. So for sports, I used to throw an implement that would kill people.
What is that?
It's the metal ball.
My brother threw one at me one time. He was practicing, and he's aimed at
You used to kill people.
No.
Yeah.
That's what I think.
So now you know that if you say Y, I'm going to fight you, and I got a shot put in the trunk of my car, and I'll throw it at you.
You actually?
No.
Oh.
But I used to keep it in the back of my car. Her name was Tabitha. I would always mark her with a little circle of nail polish, so I knew which rusty round metal ball was mine. Tabitha always had pretty different sparkly colors on her. I retired her after college. Yeah. So anyway, back to math. No. I do